All right, hello everybody. Hopefully you are enjoying your day. I'm going to get started with the Pythagorean theorem. This is review. Guys, you did do this in grade 9, so this is going to be, there's going to be a lot to this note, but again, as I said, it should all be review. Okay, so that is why I'm putting a lot into this note. And that's why it's kind of been a bit of a bigger week with respect to lessons. But at the same time, as I said, it's review. I think you guys will be fine. Okay, so let's get started. So, Pythagorean theorem, I'm sure you guys all remember it. A squared plus b squared is equal to c squared, as you can see right here. But I am going to review it, and then next week, we're going to be getting into the other trig stuff, so Katoa. Okay, so for Pythagorean's theorem, for any right-angled triangle, so just in case you guys forgot, a right-angled triangle is 90 degrees. Correct? The area, what's area equal to? Length times width, right? Placed on the longest side, so we're going to be talking about that, of the triangle is equal to the sum. Sum means adding. Of the areas of the squares placed on the other two sides. So let me read that again. For any right-angled triangle, the area of the square placed on the longest side of the triangle is equal to the sum of the areas of the squares placed on the other two sides. Okay, so what does that mean? So if you guys were to look right here at this triangle that I have set up, we can see that the longest side of this triangle, let's see what this blue is, this guy here. Okay, if you remember, it's called the hypotenuse. What it's saying is the number of squares in here is the number of squares here and here. Now let me show you. So what that means is, as you can see, I'm going to look at A first. Yeah, let's do A. We got to count the number of squares. So you can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so there's 16 squares there. Another thing that you could have done is 4 by 4, right? Because if we look at, for any right-angled triangle, the area of the square, area is equal to length times width, which is 4 by 4, which is 16. Okay? Now let's do it again for B. Let's use a different color. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Or we can look at it as 3 by 3. Right? 1, 2, 3, 1, 2, 3. So area is equal to length by width, which is 3 by 3, which is 9. So it says the area of the square placed on the longest side of the triangle is equal to the sum of the areas of the squares placed on the other two sides. That means if I add, so the sum, oops, I want to use the pencil, the sum, I should have stuck with blue, of these two numbers should give us the number of squares for C. So 16 plus 9 is 25, meaning C, there should be 25 squares in here. Okay, so what I'm going to do is I'm going to go back to black because that's what I used for A, just for colors. So there was 16 blocks in there, so I'm going to count 16 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now I'm going to go back to purple, because that's what I used for B, and count out 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That fits perfectly, meaning the sum of this and this put together, 16 plus 9, gives us 25, which is what the sum of that one is, or the number of tiles there are. So that's all fun and dandy, but the numbers aren't always that nice. So we're going to have to start using an equation to calculate this so it's easier. Okay, so 5 by 5, which gives me 25 blocks total. So that's what Pythagorean's theorem is. So that means the area of C, so length times width of C, is equal to the area of A plus the area of B. And that's what that's saying, okay? This is just proving it, okay? Because some of you would be like, oh, well, why is that the case, right? So that was just a little review. Now, again, I'm going to go over a couple more things. So C is the longest side. C is always the longest side. So you can see it right down here. Of a right angled triangle. It's called the hypotenuse. Do you remember that? Okay, so that's this guy right here. Longest side. And that's also what we're talking about up here. Okay. It's called the hypotenuse. And it is opposite of the right angle. Okay, here's the right angle. The 90 degrees, it's always opposite it. The other two sides are called legs and labeled A and B. Okay, so when we get our formula, oopsies, we have C squared is equal to A squared plus B squared. Again, this should be review. But it is really good for us to go over it because, A, it's important, especially with carpenters. I know that's one of the bigger trades that do use it. I know there are others, but I know carpentry's huge, right? Because the triangle's the strongest shape. And actually, I got a cute, funny, not cute, little story. My brother he bought a cabin about a year ago, and he's building this shed, and he's just using all this bit scrap material. And so he's putting up the poles, but he's nailing wood to these poles so they stay sturdy while he puts the roof on. Then he's going to take them down. Again, probably you guys would probably understand that more than me, regardless. So he said something about X's, and then I said, well, maybe you should put like a triangle base there, just for sturdiness. He's like, why should I put a triangle? Like, X is the strongest shape. And I'm like, so if you look here, if we have it set up, here's a pole, and he had a plank of wood like this and a plank of wood like this. He's like, well, X is stronger. I'm like, well, Charlie, that's technically two triangles, because there's a triangle there and a triangle there. Almost a triangle here and here, too. And he's like, oh. And I'm like, yes, that's that. He doesn't like when his little sister, proves him wrong. Anyways, so a reminder, this only works for right angled triangles. Okay? In this course, so for grade 10, we're only dealing with right angled triangles. Next year in grade 11, you're dealing with non-right angled triangles. Okay? So you're going to have to learn how to do it without that stuff too. And this does come up again in grade 11, I'm telling you now. Okay, so we're going to use this equation, we're going to do some practice questions, and we're going to do a couple word problems. Excuse me. Okay, label your sides. Okay, so calculating unknown sides. So what I'm also going to do is I'm going to go and use a calculator to do these calculations so you guys can see. Now, the thing is, those of you that have a scientific calculator, you can put yours in a different way. So what I want you to do is when I'm going through this note is put it in your calculator as well. and make sure you get the right answer, because if you don't, I have to show you how to put it in your calculator, and so we'll have to talk about it, because this is one of the main reasons why students would lose marks, is they show all their work and they do whatever, but if they can't put it in their calculator properly, they can't get the final answer, right? So just a heads up. So please, as I'm going through this stuff, actually try it in your calculator. And one thing I'm going to also do too is I'm going to show you here these different, like just another way of drawing it out. So kind of like what we were talking about with this example. Sorry, I'm going to go back. So we have 4, 3, 4, and 5. So with this, what I'm going to do, so these dots from one dot to the next represents 1 unit, okay? It's not like a centimeter or anything, so I'm sorry if you can't see it. What I'm going to show you, I'm going to do show side lengths. I'm going to make this, oops. Oh, this can be very finicky because I'm on my iPad. I can't zoom in. Ah! Yeah, because I can't see. There we go. Okay. So, this guy, I'm going to make it 4. So 1, 2, 3, 4 things tall. You can see there's that 5. 1, 2, 3, 4. Showed side lengths. There's 4. Okay. So what I'm going to do is I'm going to make that side length 4. I'm going to make this one 4 as well. Okay. So there you can see that my square is 4. It's a 4 by 4, just like it is here. Now I'm also going to do a 3 by 3. Ooh. There we go. There's a 3 by 3. So what I'm going to do is with this red guy, I'm going to put it on here just like what we had before. So I'm going to make a red square. There, 5 by 5. So then as you can see, the length of it, of the hypotenuse along the side, is 5. Okay? So when we go down here, we're going to calculate it, okay? So this is the exact same thing that we just showed. So we know that the answer in this case is 5, but we're going to actually use the math for it. So label your side starting with C, and then add an AB. Okay, so let's do that first. So I can use blue for that one. So C is actually already labeled, which is nice. Now I'm going to label A, and I'm going to label B. And it's just nice and easier so you don't mess up your numbers, okay? Okay. Substitute your values into the formula C squared is equal to A squared plus B squared. Okay. So I'm going to write out my formula. And I'm going to put those numbers in. So A is equal to 4, so that number is going to go in there. And B is equal to 3, so that number is going to go in there. Okay? So it's going to be, now remember, because we're subbing a value in, we should put it in brackets. So 4 squared plus 3 squared. Okay. Now we're going to do 4 squared. We can't forget about this guy here. So 4 squared, so that's 4 times 4. So 4 times 4, if you know that off the top of your head, that's perfect. That's 16. 3 squared, 3 times 3 is 9. Oops. So c squared is equal to 25. So if we have this as a square, we would know that the area of this is 25. Okay? But we don't want c squared. We want c. So we need to get rid of this square. The opposite of a square is a square root. Okay, I'm not going to explain why, just because I don't want to boggle your brains. So that means we have to take the square root of 25. So I'm going to go over here. Now, because of this calculator, I'm going to do square root 25, no, is equal to 5. Sweet. Okay. Again, guys, put that in your calculator. Make sure that you actually do it. Okay. Alrighty. Let's do lots more. Okay. So, first thing we do is we label it. Part of it's already labeled. I'm just going to go back and start using one color. I'm going to pick a nice little purple color. Okay. So this is my C. C is always here. This one's B. It's already labeled B, and so that means this one's going to be A. It does not matter which one's A or which one's B, okay? Honestly, it doesn't matter, guys. Hold on. I'm just going to take a little sip of my coffee. Okay, now we have those labeled. Let's plug it into our equation. Okay, so we've done that. So C is equal to 13. A is equal to 5. And B is equal to, well, there's nothing. So it's just going to be left as B. So what are we trying to isolate, or what are we solving for in this case? We're solving for B. So we need to get B by itself, right? So what do? Oh, I hope you guys said it. Left side or right side? Yeah, you're absolutely right. Okay. So one thing I'm going to actually do is I'm just going to solve these squares first just to get rid of them. Okay. So 13 squared, what is that? 13, is there no squared button? To the power of 2 equals 169. Okay, 5 squared, 5 times 5, I'm going to tell you right now, it's 25 plus b squared. Okay, so is b squared by itself? No. How do I get rid of it? Well, I need to get rid of this 25, so it's by itself. So how do I get rid of positive 25? I do minus 25, and then I do minus 25 here. So those two would cross out. That's going to give me b squared, 169 minus 25. Oops. It's already in there, so I'm just going to add in minus 25. 144. Okay, is b by itself yet? No. Okay, because it still has that. How do we get rid of a square? Square root it. Okay. What's square root of 144? Square root of 144 is 12. If you already knew it off the top of your head, good for you. So that means b is 12. Let's square it up. I like when we square it up. One thing I'm going to show you is I'm going to go back to that app. So we have 15 and 13. So I'm going to go to this, and I'm actually going to show you. So what I'm going to do is I'm going to move the blue. Oops. I'm going to move the blue out of the way. Okay, so, we have 5 at the bottom, so I'm going to make my green 5. There. Okay, so that's 5. My hypotenuse is 13. So I'm going to put that up there. And I'm going to make it so this side length, oh my goodness. It's very finicky, this guy. There we go. Okay, so I have to make the hypotenuse 13. Oh my goodness. I'm starting to get annoyed. Maybe I won't use this anymore. Okay. Oh my goodness, this is not going the way I want it to go. Clear it. Try one more time. Okay, there's my 1. Okay, let's go back up here. This is 13. Let's see if we can make this 13. So it's got to be on that line somewhere because it's a right angle triangle. Oh, there we go again. Aha! There we go. Okay, so I've got my 5 box and I've got my 13 box. So for me to line this up dot to dot, it should equal 12, which it did. All of that, eh? Whatever. Sorry that I put you guys through that. Now to make it a perfect square. There. Okay? So, 12, 13, and 5. Oof. Okay, so what do we have to do here? Oh, we gotta find 2. So, I gotta find this guy, and I've gotta find that guy. So, what I'm gonna do first is I'm gonna look at this as one triangle. Okay, so don't get overwhelmed. There, let's just look at it like this. Okay. So we can ignore that. So all we're doing is we're solving this one triangle where this is my unknown right here. Okay, that's my x. So let's set it up. C squared is equal to a squared plus b squared. Okay, what's my c squared? It is 15. What's my a squared? Well, I'll label this A and I'll label this B. So my A is 7. My B I labeled as X, so I'm just going to throw an X. Okay. Let's square it out. What's 15 times 15? 225. What's 7 times 7? It's 49. Okay, is X by itself? Nope. What do? We have to get rid of that 49. Right, way back to first unit. I told you the importance of it. 225 minus 49. 176. Now I have to square root that, right? To get rid of that little 2. I'm just going to go into the next question a little bit. 176 square root. $13.266499161.4. So let's say 13.3. And that's okay. Decimals are okay. Okay? So we know now that this is equal to 13.3. So I'm going to get rid of that, and I'm going to get rid of this table. Or that square. So this is now equal to 13.3. So now we have to do it again. So I did this triangle as this color. I'll do this triangle. So let's set her up. Sweet. Okay. C squared, we have it labeled as y, so I am going to put that as y. A squared, again, it doesn't matter, so I'm going to throw in my 13.3. And what's my b? It is 14. So again, guys, you guys don't have to do as many steps as I do. If you guys want to do a little bit of a shortcut, you can. Okay. So, y squared. What's 13.3 squared? To the power of 2 is equal to 176.89. What's 14 squared? $196. Okay, we're going to add those two together. $372.89. Now we got to square root that. $19.3. Okay, that's my answer. So again, guys, when I go through this, I recommend that you try it and then check your answer with me. Okay, maybe you can do it for the next one. Okay, let's go. Let's do her. So this one, there's no diagram. It's just labeled. Whoa. C squared, we don't know, so I'm going to leave it as a C. A is 3, and B is the square root of 4. Okay, so C squared is equal to 3 times 3 is 9. What on earth is 4 root squared? Well, I'll show you. the square root of 4. Actually, I'm going to put some brackets in here. Bracket, square root of 4, close bracket, just so it's around the whole square root, to the power of 2. Does anyone have any guesses? It's 4. Because the square and the square root cancel each other out, right? It's 4. 9 plus 4 is 13. Square root, c is equal to square root of 13, 3.6. Voila! Not too bad, eh? Okay, so now what we're going to do is we're going to set up some word problems. I do have 4 here. I don't think I'm going to do all 4. So the only difference here, guys, is that you just have to make a diagram with it. Okay? So literally do it as it's drawn out. And it's not, honestly, it's not that bad. You just have to draw it out, like I said. Okay? So, first thing you got to do is make a diagram. Okay, let's make a diagram. We can do this. So, a ramp is to be constructed with... Okay, so a ramp. A ramp looks like this. And remember, we're dealing with right angle triangles, so I'm going to throw in my right angle triangle. With a base length of 9.6 meters, okay? And a height of 0.8 meters. Okay? What is the length of the ramp along its surface? So we're looking for this. That's it. Label your sides, A, B, and C. Okay, we can do that. We know that this is C. Well, we can make this our A, and we will make this our B. Sweet. Okay, write out the formula. Sure, I can write out the formula. Substitute known values into the formula. Okay. Actually, let's go orange. So our known values, 0.8. And what's our B? 9.6. What I should do is this. Yep. Okay, so you see how I just put those in? Solve for the unknown. Okay. Let's get my purple back. Purple back. Okay. C squared. 0.8 squared. 0.64. 9.6 squared. 92.16. Add the two together. 92.8. Square root of the answer, because it's my most previous answer, is 9.6. So, it's meters. Same length. Huh, look at that. Pretty much same length of the base. So, word problem ends in words. The length of the ramp is 9.6 meters. Voila. Easy, eh? Okay. Each side of a checkerboard measures 40 centimeters. What is the length of its diagonal? So a checkerboard looks like this, right? You could fill in every other box. Okay, so on and so forth. So each one's 40. It's a 40 by 40. It's a perfect square. Well, you're just like, well, how on earth do I solve for this? Well, it's the diagonal that you want, right? So it's like this. So we want this guy here. So we're going to use this number and this number. So this will be my A. This will be my B. This will be my C. Easy as pie. It's 40 squared, 1600. 40 squared, 1600 plus 40 squared, or 1600 again, 3200. Now we gotta take the square root of that. C is equal to 56.5, 56.6. Okay, so remember our hypotenuse is always the longest side. So this is correct because we know that this side is longer than this side. For our previous example, I know we said it's 9.6. Technically, it's 9.63, which is longer than 9.60, so it still works. Okay. Okay, so guys, with this one, I'm going to go through them really quick. Okay, just for time's sake, check your answers. And as I said, do them ahead of time. Check your answers, see how you do. Okay? So I'm going to whip through them. I'm not going to talk as much. And then you guys have your practice questions too. Okay? Therefore, the ladder is 3.9 meters away from the wall. Okay. Boat leaves a dock. Yeah, I'm going to get all artsy again, okay? Just because I feel like it. Oh, I'm going to move this down a little bit. I find that the pictures help. Yeah, I know. Remember, never eat shredded wheat. How far is the boat from the dock? Well, we've got my C, my A, my B. Therefore, my boat is... That's a 5, I promise. Okay, guys, I know that was long, but it should be review. And, yeah. Okay, practice. Oops. Practice, and let me know if you need help. That's what I'm here for. Okay, see you later.